嗨，大家好，我叫 Jack 刚之间。去年我在这里看到很多朋友，很高兴看到现在有这么多人。那去年我演讲的时候，我是用中文，然后有点中英文。那我同事说那样子说的话，这个翻译机器会糊涂了一点，所以对不起。那我今天我就用英文讲，讲慢一点，比较清楚一点给大家听。So today I want to talk about RISC-V everywhere and what we see. You know, at SiFive, we're a commercial company, trying to sell commercial IP and make money. We had an earlier panel discussion today about, how can RISC-V make money? So along the lines of that, I want to share what we see from the commercial aspect, because I think everybody is very excited, and everybody talks about a lot of different markets and regions and areas and products that RISC-V is going to go into. So I want to share with you kind of the commercial aspect from RISC-V is actually the same. So we see tremendous momentum for RISC-V in real products, in real companies, shipping real volume of real devices. Not only here in China, but also around the world. So we see this in different markets. So automotive is one of the fastest growing markets. It's getting more and more electronified. The electronic infrastructure of how it's being developed is different. EVs and autonomous driving are changing the architecture of the car. A lot of that's being led in China, but a lot of that opportunity to develop new software means they are very accepting of a new architecture like RISC-V. So we see that demand from the SiFive side, and we see our products then getting certified with functional safety and cyber certification for automotive. Recently, NASA finally announced the HPSC, which is a next generation computer for all satellites, autonomous rovers, rockets, satellite space systems, all built on top of RISC-V vectors, actually. AI is driving tons of new projects. We'll talk plenty about AI, but I think RISC-V and AI go together, as many people have said today, in a lot of new markets. We see on the consumer side, Android being ported for RISC-V. We see a lot of consumer applications, AI PC, going towards RISC-V. And finally, we also see server, application-specific servers, very high performance, RISC-V, many core, many cluster type applications. I think later today, we'll talk more details about the 870D, brand new product we announced, highest, I believe, RISC-V performance that's available in the market today. We have customers already with that RTL. So all these different markets are adopting RISC-V. And we're going to talk about why. This did not happen overnight. I think sometimes we talk about RISC-V, when did it start? RISC-V, when did it start? It was invented, started as a project at UC Berkeley in 2010. RISC-V Foundation, SiFive around 2015, 2016. China, this is the 4th year, the China RISC-V Summit. So along the way, the last 8 years, we've had to demonstrate that RISC-V can ship in commercial projects. Customers have to be able to take RISC-V products and make it into successful commercial products that they can ship. So people are asking, how can RISC-V make money? We have to let our customers also make money. So only by demonstrating that and demonstrating quality, demonstrating that the product works, demonstrating that it's competitive in the market, can you then expand into more markets. So the previous page is a lot of new exciting markets, but it took a lot of work to get there. So right now in the field today, especially on the embedded side, kind of deep embedded type products, SiFive, RISC-V is shipping in many products. So these are all products that you can buy in the marketplace, in the field. We're inside mobile SoCs. It's not the main application processor, so people don't maybe hear about it, but it's inside these devices. It's serving as a security core. It's serving as the boot up core. It's the ISP engine. It's these other little CPUs inside the mobile device. It's inside camera sensors, inside optical image stabilizers. We're the controller in many, many SSD devices. Memory controllers need CPUs. A lot of that is RISC-V today. We have FPGA platforms. We're inside network switches, IP cameras, surveillance cameras. These devices all are shipping in the hundreds of millions of SiFive. Wi-Fi Bluetooth module, laptop docking stations, smartwatches. These are the type of applications that we've had to work on for the last 6, 7 years to prove ourselves. As a community, a RISC-V can work in these things to then go into these larger, kind of more sexy markets, if you will. So SiFive, we see ourselves as a trusted partner for RISC-V. So we have over 350 design wins. I think everybody knows the silicon design cycle takes a very long time. So if we talk about the products that are in the market today that are shipping, those are design wins that happened 4 years ago, 5 years ago. So when we see the curves of the exponential growth, I completely believe that because I know that I have a lot of other customers right behind those that haven't shipped products yet. So there's 350 different design wins, different customers, including all the top semiconductor manufacturers, multiple automotive OEMs, data center customers, storage customers, in the US aerospace and defense customers. So we see today, conservatively, over 2 billion chips in SiFive cores. Those are chips. We're not counting cores. Inside each of these chips actually has multiple cores. So you have to demonstrate shipments. You have to demonstrate the product works. And then you can evolve your roadmap to more things. But fundamentally, going back, why is RISC-V being deployed everywhere? I think there's 3 main reasons I'll talk about today. The first is innovation. Because RISC-V is an open standard, it creates an ecosystem of partners, customers, competitors, and we're all forced to innovate and develop the best products. And because it's an open standard and everybody can develop RISC-V, whether it's for your own project, or you're an IP company, or you're a chip company, or you're OEM, you can get whatever it is that you need for your project. So now we see RISC-V being developed for every possible application, from small sensors that we showed you, to large data center, to supercomputers. So the diversity, the amount of different types of RISC-V cores is going to be larger than any other ecosystem. And because of that, we will have the best products, because each product can get exactly the core that they need. And because we're going to be in the most amount of products, we're going to have the largest software ecosystem, because you have to develop software for all of these different applications, and wherever they overlap, we can share the software. So we see this in the ability to continue to invest in different markets. So embedded microcontrollers, MCUs, that's a market that continues to see more investment, not only from SiFive, but from the RISC-V community into that market area. Whereas, frankly speaking, the other companies, ARM has reduced or eliminated their investment in those areas. That's because the diversity of choice from RISC-V is overwhelming. Next is the freedom. Because it's an open standard, because you can build your own RISC-V, it opens the door for new business models. Whether it's IP, system, chiplets, custom solutions, that's why we see so many companies all working on RISC-V. And we all have to find ways to work together that are not just bound by the old traditional business models or the old supply chain. Because RISC-V is new, we have to be thinking about new partnerships and new ideas. And that's one of the things I deal with a lot when I talk with my customers. How do you want to work with us? How can I help you solve your problem? How can I get you to where you need to be? We have to be very open-minded about what it can do. It's not just replacing what existed with something different, replace ARM with RISC-V, replace x86 with RISC-V. We have to rethink how we work together in this business model. And finally, this means we have continued product improvement because there's always competition. So from a commercial viewpoint, just because I have the best RISC-V product today, it doesn't guarantee I'll have the best RISC-V product tomorrow. So we have to continue to work very hard to make our customers successful. And ultimately, this makes it a better product for everybody. So I see a shift to RISC-V for performance and for AI acceleration. This actually feeds into my next slide, which I'll talk about, which is what the modern computing needs. But we see this request for more performance, more acceleration, whether it's in the consumer space, the infrastructure space, or the automotive space. It's all really at the end the same. And what I call this is modern applications. So what do modern applications actually need? It's actually a combination of high performance compute large-scale, high-performance general-purpose CPU scalar compute, and then you have a high-performance accelerator. Now, right now, everybody, when you talk about accelerator, everybody thinks about AI. AI is definitely a use case, but it's just one of multiple use cases. AI is just a very popular use case where you have an AI accelerator next to a general-purpose CPU. But the accelerator expands beyond just AI. We see applications like in automotive, you want to accelerate your motor control. You might want to accelerate your camera computer vision. You might want to accelerate certain math functions, math libraries, because you have some particular algorithm you want to run in your database device. Modern applications need the general purpose compute, the orange box, and it needs the accelerator, which is the green box. RISC-V, SiFive, has solutions for both, and they're both based on RISC-V. So on the left, in the orange box, the traditional CPUs, you have your application processors. You have a lot of choices here. Krista talked earlier in this morning about standardizing application processor profiles so everybody can share the same software, so all the Linux stacks, Android stacks, whatever you have, all runs the same on the scalar side. Then you have the accelerator part. Here, this is where customers differentiate. This is where you develop your product, you have ways to differentiate what you're doing. Often the times, this comes in the form of a hardware engine. You have a hardware engine, a hardware accelerator that's doing something very particular for your application. Now what happens is, hardware by itself, how many times have we said this? Hardware by itself doesn't matter without software. It's very hard, it's very expensive to maintain a programming model for custom hardware that you have. So what people really want to do is they want to connect their hardware to a programmable engine, and that's our intelligence family. So it's a vector CPU, RISC-V vector standard, and it lets you tightly couple and connect your own hardware engine to it. So what happens is then there's different ways that people go to market. You can connect your own hardware engine, or in our case, SiFive also provides matrix engines that can be connected directly in a tightly coupled solution. But the point of this is, no matter what you're doing here, in the orange box or the green box, everything is built on RISC-V, which means you can use RISC-V standard tools, RISC-V standard software, and you have one programming ecosystem for your entire application. And this lets you evolve your hardware over time, but continue to leverage the same software that you have with RISC-V. That's why when people talk about RISC-V plus AI together, it makes sense because it makes the software programming much easier, much more scalable. So again, from the commercial aspect, why is RISC-V going everywhere? It's because it's enabling customers to differentiate. It's enabling them to differentiate their hardware while sharing in the software ecosystem. Because we talked about the freedom to innovate, we talked about the new business models, and at the end, it's the ecosystem. So last thing I'll conclude with, it's very important if we want to move to RISC-V, SoCs today are not made of one CPU. SoCs are very complex. There's many, many cores on that device, and we need to have CPU solutions, RISC-V-based CPU solutions, for all of those cores. That's the only way that we can move the devices completely to RISC-V. So SiFive has invested the last 8 years in developing the largest portfolio of RISC-V cores, from small 32-bit embedded to 64-bit real-time to application processors to the green, vector-based processors, functional safety cores, so that the customers can move the entire platform to RISC-V. So finally, we kind of talked about the ecosystem. This, at the end of the day, is RISC-V's greatest strength. Because we all share in the common software ecosystem, we can all focus on what matters for us and get that leverage to move faster. So RISE is just one example. There's plenty of other examples, especially here in China, of coming together and driving towards a common ecosystem. And I encourage everybody to do this and do it in a way that lifts the tide of all boats. Because in certain cases, we might be competing, but the larger we grow the RISC-V ecosystem, the better it is for everybody. I really believe it's the fastest growing software ecosystem. If we look at where it's going, the number of things that work for RISC-V that are being developed, that are being imported, it's going to be larger than any other ecosystem that ever existed. So we're at the very beginning. I know people are really excited and they're looking at stuff, but we're at the very beginning of a very large journey. But we see the signs of success. We see the adoption. We have to keep developing high-quality products that enables customers to develop things. And last one, I'll close my closing slide. This is our brand new development board, SiFive Premier P550. You can see it at our booth. We actually work together with Isue to do this board together with their chip. This is really important. This is the 3rd generation out-of-order core from SiFive. So you can really check the quality by having multiple generations of silicon. That's how you get the quality. That's how you know the bugs are out. That's how you can continue to develop new things. And I think this will be very important for software developers everywhere because nothing accelerates software faster than having actual hardware for everybody to play on. So I encourage everybody to come to the booth, take a look at that. We have another talk today that gets into some of the technical details. But I just want to tell everybody, it's a long journey. So we have to all work very hard. But RISC-V is really, truly going to go into every single market. It just takes time. Thank you.